Okay. So you see, if the hosting didn't work, let me know.
Oh yeah, no. Yeah, I'm just gonna share my screen.
Going on.
Okay,
Excellent.
cool. Cool. Yeah, can you hear me?
Yes.
Yes. Okay, great. Cool. Well, thank you for having me. My name is Allison. Just a little bit more about me. I am originally from Pennsylvania, and then I went to undergrad at UC Berkeley and grad school in ecology at UC Davis. And I just graduated just like a couple weeks ago. I'm in Danielle Karp's lab, if anyone is familiar with that. And I study how land use and climate change affect tropical birds. So as part of that, I'll be presenting just a piece of my dissertation today. Another thing I'll be presenting is more of a community conservation project and then a group project I did with my lab. I'm currently based in Boulder, Colorado, and I moved here in September. And I might be coughing a little bit because I'm recovering from COVID from last week. Okay, so yeah, I'll begin. I'll give a little background.
Allison, I'm going to interrupt you just for a second. Do you
Okay.
want to go on and put your view on full slideshow? So
Oh, is it not on full? Oops. Okay, I didn't realize that. How about now?
yay.
Allison, before you get started, I want people know Allison will entertain questions after she finishes each section.
Oh yeah, I can definitely pause for that, but I don't know if I can see them right now. So if someone could like read them when they're there.
Go in the chat, please, and we will read them off, and Allison can answer them.
Sweet. Okay, I'll just jump right in. So my presentation is called Local and International Bird Research and Conservation Using Nest Boxes. So if you don't know what nest boxes are, they are artificial boxes that are made for birds that rely on tree holes to nest or roost. And they're very useful because in urban areas or basically any human-dominated areas, people cut down trees and that destroys the habitat that these birds might need. And so these nest boxes, for one thing, can be used for conservation in certain areas. And not only for birds. So boxes are also used for conservation of mammal species, such as the squirrel glider in Australia. Nest boxes are also used for pest control by farmers. So in this case, this is an owl box used to attract these owls that might eat rodent pests in vineyards. And there has been research on this in California by Jedlicka. And she found that putting bluebird boxes in vineyards also helps the farmers because the bluebirds will eat insect pests. And finally, nest boxes can be used for research. If you imagine researching bird nests, it can be very hard to find the nest and then monitor them if they're very high up in trees. But nest boxes make it very easy because birds will just be willing to use them and then they're in the exact location that we want them to be in. And then we can also monitor them or adjust the conditions based on what we want to study. So this is a project from UC Davis, actually from a postdoc in our lab about how climate change might be affecting nest success. And nest boxes were used for this project. And nest boxes were able to be monitored for temperature and also for all the metrics for the chicks. So here's an overview of my 3 projects. First one is located in Davis. It's about how suburban conservation of bluebirds and tree swallows using nest boxes. My second project is actually in Northwest Ecuador, and it's about how agriculture limits nesting resources for cavity nesting birds. And finally is the group project I'm talking about with my lab, and it's about how agriculture and temperature extremes synergistically erode reproductive success across the continental United States. So 3 very different locations and like geographic scales here. And again, I'll take questions in between each so people can remember, because these topics are pretty different. And then at the very end, if people have any more questions, I can also take them then. All right, so first for the conservation project. The background for this is there is something in Davis called the Poudre Creek Nest Box Highway. Well, not just Davis, it's in Yolo County. It began in 2000 by a grad student at UC Davis, actually. Her name is Melanie Truen, and she still works at the university now, which is really cool. So there are 200 hanging nest boxes along Poudre Creek. There's a map here below, and there's about 20 miles that these boxes span. And they're all in riparian, like natural habitat. And over the last over 20 years now, over 15,000 birds have fledged out of these boxes of a bunch of different species, including tree swallow, western bluebird, ash-throated flycatcher, house wren, and white-breasted nuthatch. And before this project started, there were very few cavity nesting birds at this point because of habitat destruction, like I was talking about. And now you can see many of these species, a lot more common, which really shows it made a really big difference. So I moved to Davis in 2017. I lived in a suburban area in North Davis. And I was wondering, well, are these birds spilling into suburban habitats from these natural habitats? And then are they lacking nesting habitat? Would nest boxes help support their populations? Indeed, so the birds from Poudre Creek are banded, and they can be resighted sometimes. They're not tracked, but sometimes they're observed, and then you can see which nest they came from. And the furthest movement from a bluebird from Poudre Creek was 23 kilometers. And the furthest movement from a tree swallow is further, it's 80 kilometers. So the tree swallows tend to migrate a little bit and move more. But this just shows that they're definitely able to be going into suburban habitats and potentially looking for more nesting habitat. All right, so this is the location. On the left is a map of Davis, if you're familiar, and I lived really close, basically in that red rectangle, and there's a green belt there, kind of like a network of parks, and I had the idea of putting nest boxes along that green area. On the right is just a zoomed in map. This is like a satellite map of that same area. And those yellow points are examples of the boxes. That's most of the boxes that are there. So we have a bunch of hanging nest boxes, which I'll explain later, that are CG1 through, I want to say 15. And then on the very top right, there is CG 17, 18, 19, 20. There should be a 16 in there. Those are in this new uplands habitat that was created by the city of Davis. So there's no trees in that area, so those boxes will be on poles, and I'll show a picture of that. So I had this idea and began it in 2019, and I had to work with the city of Davis to allow me to place boxes in the parks. I also worked with the Museum of Fish and Wildlife that runs the Poudre Creek Nest Box Highway, and that was super helpful because they had all the materials and existing protocols that I could use. And then the local community members in the area, including Gene Jackman, were very supportive. On the left, there's a picture of a hanging nest box, and in the middle, you can see there's a nest box hung there, and they're hanging to deter predators. When a box is on a tree trunk, it's easier for predators to climb up. And so in the middle, we have Chris Gardner from the city of Davis, and then Melanie is also in the picture in the middle, and on the right, who is the person who began the Poudre Creek Nest Box Highway. On the right is a picture of a pole-mounted nest box. All right, so with interns, I monitored the boxes once a week, and that's very important in order to maintain them, make sure there's no pests, make sure the birds look healthy, and also just understand how we're affecting conservation. And we recorded many things, such as bird activity, nest building progress, the number of eggs and chicks, the growth of the chicks, the number of fledged, and any evidence of predation. We also recorded sightings of other birds that were banded so we can see where they came from. And this is just, these pictures just show how we get the boxes down. It's like an extendable pole with a little basket on it that can swivel, and it's pretty neat. So there are two species that ended up using the nest boxes. On the left with the Western bluebird, and they begin a nest using dried grasses, and their eggs are blue. There's usually 4 to 6 or 4 to 5, usually 4 or 5 eggs. On the right, we have tree swallows, and they begin their nest using feathers, and they also line the cup of the nest using feathers. Their eggs are smaller and like cream colored, and there's usually 5 to 6. So here is a process of some chicks growing up. So these babies were just born, and they're really tiny. This is when they're a little bit bigger. On the left is tree swallows, and on the right, they're bluebirds. And then this is us measuring a bird, and there's a special ruler that's pictured on the top to measure something called the wing chord, which is the end of the wing, the tip to that little joint that looks like an elbow. So in this case, it'd probably be about 12 millimeters. And we use that measurement to understand, first of all, how fast they're going, but also when we can put bands on them. I think there's someone in the waiting room, by the way, if anyone wants to admit them. Okay, so once they're old enough to band, we take even more measurements and we put bands on them, which I'll explain. So the reason why we have to wait for them to be a certain age is that when they're really little, their legs are pretty fleshy, and actually the thickness of their legs is too big for the bands to even fit. If we band them when they're too old, we risk disturbing them and having them fledge early, which is not good for their survival. So there is an ideal window of time that we like to band them. So this is us banding some bluebirds. On the bottom, the bright blue indicates that it's a male, and the females are more turquoise colored, which is the upper photo. We take measurements of different parts of their body, such as their skull, their bill, their legs, and their wings and tail. And we also give them a fat score, that's what we call it. We see how much fat they're storing, and birds store fat in this like triangular shaped hollow near their chest, and that's what we check. And then they get bands. So every bird gets a silver band with a unique number on it, and those are provided by the USGS, which is like a government agency. So those are consistent across the US, and if you see a bird that has one, you can read the number and see where it came from. They also get 3 colors that identify which nest they came from. A funny thing is that tree swallows only get the metal band because their legs are just too short to put more. They can put 1 color band, but then there aren't enough combinations to, fulfill all the nests. So it's not worth it to put color bands on those guys. And then this is what they look like when, I think this is their cutest age. And we put them back in the nest, and then we don't disturb the box for 2 weeks. And then when they come out, this is what they look like. They stick around the nest for several weeks with the parents, looking for food and learning how to be a bird. And then this is a graph that's made using the Poudre Creek data, but this just shows that there are waves of activity. So in the blue, we have total eggs, and the time of the year is on the x-axis. So there's a large peak around kind of the beginning of May, and then birds will nest a second time often, sometime in June, and sometimes they even nest a third time. I found that in Davis Parks, because they're irrigated, the conditions are pretty good. There's like a lot of good food around. I think the irrigation keeps it a little bit cooler in the summer as well. So the birds are quite successful, and most of them nest twice or sometimes even 3 times. So this is the data we have since the project began. So the boxes available, I'll explain, they increased because we started with 15, and then that uplands habitat was created and we added 5 more. In 2022, we ended up adding 4 boxes in locations that looked suitable. And then if we just go to total fledglings first on the far right, you can see how they increased by a lot over time. First year, there's only 33, and then they increased sharply to 85 because it takes time for the birds to discover the boxes, and also for the population to build up for there to be enough to even use all the boxes. And then in the most recent year, there's 131 fledglings. The eggs also increased over time, of course. And then Western bluebirds use the boxes a lot more frequently than tree swallows just due to habitat. So in the Davis Parks, that's like perfect habitat for the bluebirds. They like foraging in the grass, whereas the tree swallows tended to use the nest boxes by the pond, which is in the north part of the map. So always more bluebirds here. And so for the future, I no longer live in Davis, but there's already another grad student that's taking over this project, and hopefully she'll be recruiting new interns every year. I worked from, well, over the pandemic, I had like 0 to 1 interns, but there's 1 year where I had 10. So it's a really great opportunity for undergrads to get involved in some research, even though this is more of a conservation project. And these nest boxes can be used for research if needed in the future. The purpose is conservation, so there are no like controlled variables. We just place the boxes where we think they're best for birds, and if they're not used for a few years, we'll actually move them to an area we think might be better. But my lab mate has already used the boxes just to collect some fecal samples that she needed. So there's always the potential to use them for research. All right, I think I'll take questions about this project before moving on to the next one.
Okay, there are no questions in the chat right now. So folks, if you have questions, please put it in the chat now. Let's see. If it's easier for you, you could raise your digital hand. That is. Which question somewhere? Okay, we have a question. Allison, do you think that avian influenza will affect these birds?
That's a good question. I actually haven't heard much about it. I don't know if anyone here knows more about it, like which species they might affect, but I haven't like heard concerns about that with these birds.
Okay.
Yeah, I'm not sure.
We have a raised hand by Barbara. Go ahead.
Hi, I was wondering, I mean, that you take the nest boxes down to look at them, and you handle the chicks and stuff. Doesn't it disturb the birds?
Well, they definitely don't like it, and the parents are agitated, but they never abandon the nest. It's actually like a misconception that parents will abandon their babies if the nest is handled. So we try to minimize the amount of time that it takes to handle the birds. But over this whole time, we don't think it negatively affects their health or anything.
And also putting up and down the boxes doesn't matter either, huh?
Right, yeah, it doesn't. We just try to be gentle with the lifter. Yeah.
Okay, thank you.
Okay. Okay, Kristen asks in the chat. She's a fourth grade teacher at North Davis Elementary, and she would love if you might be able to share some of your slides. Oh, sorry, I lost it. Share some of your slides so that she could show them to her class. They have a bird of the month, and her son Zane has been doing, excuse me, has been talking to the kids and taking them out to look at the nest boxes near their classroom in previous years. So wondering if you have slides to share that she could use in her class.
For sure. Yeah, you can email me yeah, after this, and I can get those to you.
Okay.
I can see the questions now, which is good. Yeah, so where do the fledglings migrate after summer? They actually stick around, and a lot of them return to the same box that they were born in the following year. Of course, not all of them can, because only one pair can use a box. But for bluebirds, I think a lot of them do stick around or just move very locally to like maybe a different park, but I don't think they migrate very far.
Okay. Barbara, do you have another question? I see your hand is raised. Oh, okay. Okay. So, okay, there's no more questions in the
Okay,
chat.
great, perfect.
And so we can move on to part 2.
Sounds good. Okay, next I'll be presenting part of my dissertation about how agriculture limits nesting resources for cavity nesting birds in Northwest Ecuador. All right, so I studied land use change, which is converting like natural habitat, in this case tropical forest, to agriculture. And that's the largest driver of biodiversity loss worldwide. So that includes habitat loss, habitat fragmentation, and agricultural intensification. This is a map of the species lost around the world due to land use change, and a lot of those species are concentrated in the tropics. So actually, a lot of species do persist and are observed in tropical agriculture. This is just a graph of the proportion of species found. If you just look at, well, the bars here in yellow, those are the species that were found only in agriculture. In green, only in forest, and in gray, the proportion of species that were seen in both habitats. So there is like a chunk of species that is only found in agriculture or in both habitats. But my main question is, can agricultural habitats sustain the reproduction of these species? Because just because they're observed there, it doesn't mean they can use that habitat effectively, or if that habitat can support their reproduction. So I focus on cavity nesting birds, and the diversity of cavity nesting birds is the highest in the neotropics, and that is shown in this map here. The darker colors represent more cavity nesting species. So in South America, where I work, there are definitely the most. And there's not that much research that's done on these birds. There's been a lot of research on nest boxes and cavity nesting birds in temperate areas, but not really in the tropics. Here below is just an example of a paper about how the supply of cavities might be limiting birds, but they look at primary and logged subtropical forest, whereas I want to look at tropical forest, and I want to not just look at logging, but agriculture. And here's a picture of a snake, which is a very common nest predator in the tropics, just to show that there's not much known about the success of cavity nesting birds in tropical areas or in tropical agriculture. So my research questions are about how the following compare between forest and tropical pastures. I looked at the abundance of cavity nesting birds, their natural cavity availability, their natural cavity use, and then I put up nest boxes in forest and agriculture to see if birds would use them, with the assumption that if birds use more nest boxes in agriculture, that means they're lacking their natural habitat because they're willing to use this artificial habitat. I also wanted to know if nest boxes could potentially be a good conservation strategy. So I worked in Northwest Ecuador, again, with this NGO called Fundación para la Conservación de los Andes Tropicales. And this is run by a professor at Tulane University. I selected some plots. Half of them were in forests and half of them were in agriculture. On the right, there's just a map of where those plots were situated. And in those plots, I conducted bird surveys. I had field assistants help me with a lot of this, but I would go every summer. So I conducted 4 rounds of these surveys over 2.5 years. I also searched for natural cavities, and then we tried to monitor them for a year, and I'll explain how that went. And then this is just a side thing that did not work out. I tried to climb the trees to monitor cavities. I brought down a ton of equipment. I got all the training, practiced, and then I realized it's just really not feasible. So in the Atlantic subtropical forest, they climb trees. So I thought I could just copy them and use their methods. But these trees are way taller, 40 meters high. So they could take a whole day to climb just a few trees. So it's definitely not feasible. But I tried this. And so alternatively, we monitored the cavities by observing them from the ground. And then I added nest boxes on every plot. So there's 10 nest boxes per plot. Half of them were the bluebird sized nest box, and the other half were larger, about 1.5 times those dimensions, just because we weren't sure what species we would get at all. On the bottom right, there's a photo of me checking the nest box. So we didn't take these down. We would use these long poles with, I think it's an endoscope. It's a really small camera attached to it. And then you can see what's going on on your phone or a tablet. So we could look inside the boxes using that. And then here's a photo of us putting up boxes. They were all 5 meters high. So I used a ladder for that. And then on the right, there's a better picture of that really small camera. It has a little light on the end. And yeah, it's just something to look into, small holes. On the left is a picture of an agricultural landscape with nest boxes. And here's one more photo of a pasture that has some nest boxes in it. All right, and then finally, I did a pilot study that didn't work out, but I thought it might be interesting to share. I wanted to know if nest boxes led to more pest control on the farms. So they're near the active nest boxes, I would put these mealworms that are pinned onto cardboard, and put them near active nests, and then inactive or empty boxes to see if more bugs would be eaten near the nest. But it really didn't work, because in the tropics, ants would just eat everything immediately, which is pretty funny. Even with these cages that we put over them to prevent other animals from coming. We would also put cages to prevent birds from getting them, just as a control to see what happens. All right, so now for the results. So were cavity nesters more abundant in forest than in agriculture? Short answer is no. So on the left, we have on the x-axis, there's agriculture and forest, and then cavity nesting and not cavity nesting species. And you can see in both habitats, there's not much difference between the cavity nesting and non-cavity nesting species. And then if we look at each species individually, we did see some that were more abundant in one habitat or another. So the collared aracari was more abundant in forest, and all the other species here were found to be more abundant in agriculture. And again, all these species use cavities. So next, as expected, there are way more natural cavities in forest. There's just so many more trees. On the graph here, we have agriculture and forest, and the natural cavities is on the y-axis. The forest bar is way higher than agriculture, and there's probably even more in forest because it's so hard to see that we probably missed a lot of them. There's also a lot more nest box use by birds in agriculture, as expected. Here on the x-axis, I sorted the boxes by the large ones and the small ones. And then on the y-axis, we have avian activity events, which includes like nesting, but also just like starting to build a nest and things like that. The highest bar here, it would be the red one in the small box size. So birds liked the small nest boxes in agriculture. Yeah, I'll get more into this later, but yeah, the boxes were barely used at all in forest by birds. And here are the species that use the nest boxes, or actually more species use nest boxes, but these are the ones that laid eggs. So from the top right across, we have plain brown woodcreeper, the Pacific parrotlet, streak-headed woodcreeper, dusky cap flycatcher, masked titira, house wren, choco screech owl. And in the table, you can see the nesting attempts of the house wren was by far the highest. So there are 30 nesting attempts for house wrens in small boxes in agriculture. The next highest was streak-headed woodcreeper in agriculture. And then the owl nested 3 times in one of the large boxes in forest. Okay, this is a picture of an owl, the owl with a baby. Unfortunately, all 3 nesting attempts were not successful, but I think at least 2 of them were the same adult that was trying again. And then here's a few photos of birds that used the boxes but didn't lay eggs. So a lot of black-cheeked woodpeckers would roost in the boxes, and we would know because we see their heads sticking out and we can see their feathers in there. These are some rusty margin flycatchers. I think they started a nest, but never laid eggs. Blue-headed parrot that's checking it out. And then we had a ton of insects use the boxes. Sometimes wasps or bees would take over. And then we had a lot of mammals use the boxes in forest. So we have the 4-eyed possum and red-tailed squirrel. There are much more mammalian activities in forest. There's 28 and only 1 in agriculture. So I'll explain what happened with the natural cavity observations because that's not part of the results right here. We would observe the cavities every week for about 15 minutes. And we found so few observations that it's not even like possible to analyze. And we think it might be because birds are much more elusive in the tropics. Maybe the cavities weren't even deep enough to host nests, but we couldn't tell from the ground. Or there are just so many cavities out there that we didn't find the right ones. So we found way more natural cavities in forests, but we weren't able to understand how many were being used. So overall, we had fairly high nesting success in agriculture. It was about 50%, which is high compared to other papers in the tropics that have found about like 25% success. In the picture, there's just a chick being eaten by ants and then a toucan that's potentially looking for eggs or chicks to eat. But it's good that we have high nesting success because it means that nest boxes could potentially be a good conservation strategy here. So in conclusion, I found that nesting habitat does seem to limit cavity nesting bird populations in tropical agriculture, but not in forest, even though cavity nesting birds are abundant in agriculture. So it seems like these birds are present in agriculture for some reason. Maybe there's food there, or something like that, but they do lack nesting habitat in agriculture. So therefore, retaining remnant trees in agriculture provides critical nesting habitat for these birds. And adding nest boxes could be a good conservation strategy for certain species, like the ones in this study. And these birds could potentially provide pest control services to farmers, as most of them eat insects. So as part of this project, one of the things that was important to me was outreach to the local community. So I was able to create this like fact sheet that talked more about my results and the species that use the boxes, and then it had instructions on how to build a nest box. And I distributed it to local schools near the field station. I also created a video that I have an English and Spanish version that I shared with everyone. And I also presented it to everyone at the local field station, all the researchers and people who worked there. So I thought that was a really cool part of this study. All right, great. I can take questions now about this one.
Okay, if you have any questions, you can put in the chat or raise your hand. Hopefully I'll get a signal to raise your hand. Allison, while we're waiting, the NGO you mentioned at the beginning of this section, they working with the farmers and ag people to get them to leave some trees. You were talking about leaving some, I don't forget the word you used, but leaving some trees, cavity nesting.
Yeah, so the NGO has a pretty good relationship with the local landowners. And also everyone who works at the NGO lives there locally. So their families are around, sometimes they have land. So the message is definitely being like translated to local landowners. And also that's why we hoped to like communicate it to schools, so kids could tell their families as well.
Thank you. Anne and Bryce?
A couple of things on the school aspect. Did you do any follow-up to see how many actually built and put up nest boxes?
No, I haven't. I just went to do that last summer. So yeah, I'm still awaiting an update.
Yeah, that would be fun to know. I also wanted to ask a little bit about your funding, because you had field workers. I mean, you obviously had some money to hire people. Where did you get your funding?
Yeah, so I had funding from the NSF, which is like the National Science Foundation. And then I got a fellowship from, it's something called the ARCS Foundation. It's for, well, UC Davis has several students that win this like fellowship that where I get funding. And then one more is the Academic Senate Grant, which is another UC Davis grant that we got. Because we did pay a field assistant year round, like half time. So he worked half the time on my project and half his time on someone else's project.
Great.
Okay.
Thanks.
In chat, we have a question. Kristen, how much monitoring of the nest boxes by humans is needed in order for the people there to be able to use this successfully as a conservation strategy?
Yeah, so I think that even though we monitor the nest boxes once a week, it's not like we would modify anything about the boxes because they're kind of out of reach and it's dangerous to like remove bees and wasps and things like that. So I don't think much monitoring is needed in this case, especially because there's just such a wide range of things that can happen in the boxes. But ideally, like in Davis, we say once a week is best in order to maintain them. Mm-hmm. We also had to replace a lot of boxes because it's so wet in that environment that they would decay or fall. So yeah, just to optimize conservation and the quality of boxes. Yeah, I think once a week would be good.
Thank you. Barbara has her hand up.
Yeah, I was wondering, I mean, if I understood that right, some species were only in the agricultural land, and I was wondering what they were. And I mean, as I see agriculture not as natural, where would they be if there wouldn't be any agriculture?
Mm. So the birds that I showed were the ones that were like more abundant in agriculture. So there were just more of them, and they could potentially be found in the forest. But species like house wrens probably were only seen in agriculture. And if there was no agriculture, they probably wouldn't be around, which is probably how it was before. So not all species, are like going to decline with land use change. And so some species will be like winners if we cut down the forest because they actually prefer open areas. Maybe they love eating like seeds that are found in agriculture, such as like sparrows. But it's not like a good or bad thing necessarily that they're increasing or decreasing. It just happens that the most rare species and most threatened ones are the ones that tend to be found in forest.
Oh, thank you. Thank you.
Yeah, of course.
Okay. Okay, oh. We have a question from Michael in chat. What kinds of mammals use the boxes in the forest?
There are two mammals. One of them is the red-tailed squirrel, and the other one is the four-eyed possum.
I thought there'd be more. Oh,
Oh, are there ways the boxes could be modified to prevent wasps from taking over? So we have not found a way to prevent that in the tropics. It's probably like certain types of trees that they like, something like that. In Davis, it's very easy. So wasps also enter boxes in Davis, but if we see them, especially early in the season when it's like colder out, you can just crush them because they're invasive anyway. At least the ones that use the boxes are. In the tropics, I don't know. I feel like it's too scary to remove them.
so you said that they're attracted to the tree, so they're
Maybe.
for whatever reason, and the box just happens to be there.
Yeah, I don't know what causes certain boxes to be used. And there must be like a lot of competition for these boxes between like different bird species, mammals, and insects. So yeah, I'm not sure what determines like which species ends up using each box, but that would be interesting to look into.
Okay, so if there are no more questions, we'll move on to part 3, the last part.
Awesome. Okay, so this is a collaborative project I'm going to be talking about. We started it over the pandemic. We were looking for data that existed already that we could turn into a project. And so the person who made this presentation is my lab mate, Catherine Locke, and I am kind of like co-first author. And then in the co-author list are all the members of our lab. So for some background, so the two most important drivers of biodiversity loss is land use change, like I mentioned, but also climate change. And these two drivers are often studied independently, but their interaction is not often studied. So we wanted to look at these two changes that are occurring at the same time and see how that's affecting birds. So I'll be talking about something called microclimate buffering. So microclimate is just a very local climate, and buffering, I'll explain it in a second. But basically climate change in North America is not only causing warmer temperatures, but more frequent temperature extremes, such as heat waves. And climate kind of describes an area's temperature, like a large area, but a microclimate would be something like getting shade from a tree, or the fact that an agricultural field is probably hotter than a forest that's really close by, just because of shade. So we found that this is indeed true. This is real data that was taken by my lab mate, Catherine. And she recorded temperatures in forest and in row crops. And in row crops, the temperatures were higher as expected. And so why is it helpful to study birds in this scenario? So we want to study the effect of climate change and then how the climate might be different between different types of land uses. And birds are something called altricial and ectothermic. That means they're born and they're very poorly developed, and they can't really regulate their body temperature very well. What that means is that they're vulnerable to temperature extremes, and heat waves are like a very common cause of nest failure or death. So again, yeah, they are not good at regulating their body temperatures. And heat waves could also potentially affect their food supply if the parents reduce their visitation of the nests if it's very hot or very cold. And they're so cute. We all love birds. So the first hypothesis here was that nests in agriculture have lower reproductive success when exposed to hot temperature relative to nests in forest, because forest provides that shade and maybe the temperatures won't be as extreme. So here, temperature anomaly just means a hot temperature extreme. So as temperature gets really hot, maybe in forest, the reproductive success would stay pretty constant. But our hypothesis is that in agriculture, because there's no shade, their reproductive success will decline. Second hypothesis is that the nests in agriculture, when exposed to these hot temperatures, have even lower success when they are in hotter places. And what that means is that a heat wave in a Davis summer is probably worse for a nest than a heat wave in the Bay Area, just because it might be like 110 degrees in Davis and a heat wave in the Bay might be like 80 something or 90. So in this case, reproductive success would go down more in a hot place, which is the line in red, and in blue, or in forest. But in agriculture, this trend is way more extreme, again, due to lack of shade. Next, we predicted that species of conservation concern and species that nest in cups versus cavities are especially vulnerable to hot temperature anomalies in agriculture again. So these are the same exact plot, but just imagine instead of hot places and cold places, we have cup nesting birds and cavity nesting birds. And we think cavity nesting birds are less vulnerable because the nest provides some insulation, whereas cup nesting birds have their nests exposed to the air more. And then in terms of conservation concern, we think that more birds that are more rare might be more vulnerable to climate. And maybe that's one of the reasons why they're more rare in the first place. So maybe those birds are the most sensitive to extremes in their environment. And finally, under future climate scenarios, we predicted that success of nests in agriculture will decline more than the nests that are in forest, again, due to more extreme temperatures experienced in agriculture. So if we have forest and agriculture here on the x-axis, we predict that the success will be lower, or the change in success will be lower in agriculture. All right, so the data we used is from NestWatch, which is a program run by Cornell. It's a citizen science database, and anyone can participate. This is a map of all the nests we have. There was over 150,000. And there's 58 species and then 22 years of data. We separated the land covers into 4 different categories. We have forest, agriculture, natural open, which is kind of like a natural habitat, but we can't call it forest. So the natural habitat with kind of like less shade, such as like chaparral. And then developed, which is like a human landscape, like a city. I'll be focusing on forest and agriculture here. So we also were able to extract temperature extremes from every year from just an online resource called GridMet. And this is what the NestWatch like data or like website looks like that you could participate in actually. So this is a homepage and anyone can create like a data sheet. And I'm presenting this as part of a Nestbox presentation because most of our data came from Nestboxes. And then this is what the monitoring sheet looks like that they give you. So it's very similar to the one we have in Davis. It includes things like eggs, number of young, the adult activities. Yeah, and you fill it in. I think they suggest you to monitor once a week without disturbing the nest. And yeah, it goes to us. Or it's actually available to the public, I think, if you want it. So I won't go into the modeling part too much, but basically our response variable, what we consider nest success is at least one offspring fledged. So if at least one fledged and others died, we still call it a success. It only fails if all of the chicks do not fledge or they don't even hatch. So key things we cared about were the hot temperature anomalies, land cover. We looked at historical site temperature, and then we controlled for a bunch of other things that I don't need to get into, but things like precipitation, the date that the egg was laid. So going into the results, we confirmed our first hypothesis. So on the x-axis, we have the hot temperatures again. And then the y-axis is basically just nest success. So as temperatures got worse, or as the hot temperatures got worse in forest, there's actually a slight positive effect on success, or like almost no effect. But in agriculture, there's a steep negative effect. So that's what we predicted. Our second hypothesis was not supported. That's the one about the hot places. So we have the temperature anomaly on the x-axis again, and success on the y-axis. And then these 3 lines here represent 3 different types of places, like a hot place, not so hot place, and a medium. But the point is that the lines are all too close together to have a say that there's a significant difference. Our third hypothesis was confirmed. So conservation score comes from this organization, I think it's like NABCI, I forgot what it stands for, but they came out with scores for North American birds, and a low score means we're not very concerned about their conservation. So a 4 here is house sparrow, and a higher conservation score means they're of more conservation concern. We have the same axes here, the maximum temperature extremes on the x-axis and the nest success on the y-axis. And here in agriculture, you can see the yellow line has the sharpest decline, and that's the bird with the highest conservation concern. Not necessarily the one pictured, but that's just an example. Whereas birds of low conservation concern, like in the purple line, don't have much change in their success with high temperatures. We also found that cup nesting species were more vulnerable. So if you look at the agriculture panel again, the red line is cup nests, and the blue line is cavity nests, and the red line declines a lot more than the blue line. And finally, we did find that nests that are in agriculture are predicted to be less successful in the future than nests in forest. So here's a map of projected change in nest success, where red means the nests on average should be less successful, and blue means they'll be more successful, and gray means no change. So you can see there's a lot more red in the agriculture map than the forest map. And there is several hypotheses for why birds might be predicted to be more successful in forests. And one of them is perhaps the hotter temperatures actually releases birds from having to incubate as much. That's just one hypothesis in forest. But in agriculture, the hot temperatures are just too extreme. So in conclusion, the buffering effect of forest protects nestlings from the lethal effects of temperature spikes. Species that reproduce in agriculture may be more vulnerable to climate change, especially those that are of conservation concern and those that nest in cups versus cavities. And finally, a mechanistic understanding of how high temperatures cause nest failure may offer more concrete conservation strategies. Because here we're looking at like a nationwide trend, but we don't really understand if nests are less successful due to temperature directly, or maybe their food resources declining. And my lab mate is doing studies on that right now. All right, thank you for your time. Yeah, I'm ready for more questions. You can ask about this project or any of the other ones too.
Okay, excuse me. Nikki, with your next nest success study, would you have found a different result if you define success differently? Example given, what would you find if your analysis took into account the number of offspring that successfully fledged?
Yeah, I think our results would definitely be more precise if we're able to know the number of offspring that fledged. That is data that is available, but we didn't use it because if you can imagine, it can be very hard for us to accurately, or for any observer to accurately know exactly how many fledged and became successful. If you visit a nest on like one day and all the nestlings are there, and then a week later they're not there, it's hard to know if, you know, any one of them got predated in that time window and then the rest fledged. So that's why we used at least one fledged. But yeah, I think I don't think that the major trends would actually change if we use total number. I think it'd be related to temperature as well, but I think it would just be more precise. Yeah.
Okay. Looking for a hand. While we're waiting, I have a question. In the field, are the agricultural practices or crops, are they recorded? So that you know if you're talking about, if agriculture is talking about corn, wheat, tree crops, is that information on that data sheet somewhere?
Yeah, I think it is, but I think row crops might be its own category, which is kind of broad. Orchards are definitely separated, and those, well, you can imagine, might provide more shade, which is good. But that was like less than 1% of all agriculture, orchards and vineyards. So we just didn't mess around with that because we think it didn't affect the results too much. But I think people are allowed to put in a broad habitat category, and then you can select from a drop-down menu of more specific things if you want to.
I was just thinking about around here, we may have red-winged blackbirds and who knows what else nesting in wheat fields.
Yeah.
Okay. I don't want to hog it, but I have another question. It's just, I don't see any more. Excuse, wait. There was another one. All right, Rose has asked, based on your research, as a conservation strategy in Davis, should we focus on planting more trees or use more nest boxes since both confer nesting success advantages?
That's a good question. So I think as a long-term strategy, trees are very important. But if you start planting trees, it takes so long for them to grow up, and then cavities are formed either by trees decaying because they're so big and old, or because woodpeckers create cavities, which occurs mostly in like softer trees, I think. But I think as a long-term strategy, planting trees is super important. If you want to conserve the birds, like in the next few years, I think nest boxes are really helpful. But then again, they take a lot of effort to monitor them. And once you put them up, you hope to monitor them for a long time because you can't then remove that nesting habitat. So there's definitely trade-offs there. Overall, of course, like planting trees is more sustainable and it would be ideal.
Okay. Let's see. No hands on. So in the nest watch, are there certain species or bird types like raptors that are excluded or disqualified from being listed?
No,
know-
you can list anything, I think, but there are, but the vast majority of the data is from nest boxes or like nests that people commonly find near their houses, like house finches and things like that.
Okay. All right. All righty. Folks are saying thanks, nice presentation. And so how important is it to clean out the nest box after each fledgling?
So in Davis, we only clean them. Well, we clean them if there's like wasps, but other than that, we usually only clean them once a year. So if a bird will nest twice, we don't clean it in between. They'll add new nesting material that's fresh. We will clean them after fledging if there are a lot of ants in there, and the ants actually do affect the nestlings. But most of the time, we clean them at the end of July when we know that they're done for the season.
Okay. Kristen has a question. It's surprising to see the increase in success among the forest birds, even with the temperature anomaly. Your hypothesis about maybe a decrease in incubation time is interesting. Is the same species being compared, or just different different locations or different species? Yeah.
Yeah, so we only included species that nested in both types of habitats in this analysis. So they are the same species being compared, which is really interesting.
Okay. I have a question that's bothered me for a long time. Who cleans a natural cavity?
Who cleans a natural cavity? Or
If you're cleaning out nest boxes, who goes out and cleans the hollow in the tree?
maybe the birds, honestly, like it's funny in the tropics, there's a lot of competition. So we'll see woodpeckers like dragging nesting materials out so they can put in their own.
Okay. Well, let me have a follow-up question to a question about cleaning. Do you use bleach or wash or brush out the box?
We use these like metal scrapers because there's usually a lot of poop on the side, but we don't use any liquid or anything like that. If there's a lot of ants, we put diatomaceous earth.
Okay. All right. I hope that answers the question. All right, folks. I don't see any more questions in chat or no hands raised. So Allison, I would, what am I doing? Wish I knew. There we go. Allison, thank you so much. There have been comments in the chat about the presentation, and I agree with them. I've learned a lot. And thank you for answering my question about who cleans it in a while. So thank you very much. And hopefully you'll come back some other time and let us know how things are going with your new endeavors.
Thank you for having me. It's been great. Yeah, and thanks for all the questions.
And folks, thank you very much for spending time with us tonight. Excuse me. And like I mentioned earlier, next month, a speaker will be announced shortly. And I hope we'll see you then. I was going to say, check our webpage or Facebook for any field trips coming up, because I don't have them memorized. So anyway, thank you very much, and we'll see you all next month.
Thanks, Ken.